Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 1.3, which is going to deal with representing and describing transformations. Now, this lesson is going to be kind of an introduction to transformations to kind of talk about what it looks like and what it means before we dive more into it in Module 2. Now, transformations just means that we're going to take a shape and we're going to move it to a different spot by either using a translation, reflection, rotation, or a dilation. Now, today we're not going to really get into the specifics of all of those. We're just going to talk about what it looks like to transform a shape and how to represent it. So, we have two learning goals for today. Our first learning goal is you will be able to represent and describe a transformation. And then you will be able to determine if the transformation is a rigid motion. So we'll take a look at what a rigid motion means and how to determine if it is rigid or not rigid. All right, so with that said, we've got some terminology to talk through before we jump into some examples. So first, a transformation is a function that changes the position, shape, and or size of a figure. So we can go through and move a figure, we can make it smaller, bigger, we can even change what it looks like. Now, the inputs of the function are the points in the plane, and the outputs are the other points in the plane. Okay, so the input would be the original image, and then the output would be, after applying the transformation, what it looks like now. Now, a figure that is used is the input of the transformation, so it's the pre-image. So the pre-image is going to be the way that we refer to the original, and then the image or the output is going to be the transformed. So if we look at point A here, point A is our pre-image, and it was translated along this vector to its new spot or its now image. Okay. Now, a way that we can kind of go through and keep track of what point was moved where or what happened to it is we keep a little bit of a notation, and that's going to be prime notation. Now, prime notation indicates the image of a point. So if the original or the pre-image of A was here, it was translated along this vector to its image, and we're going to refer to that as A prime. Okay, a prime is just going to indicate that that point has been transformed to this spot. Okay, and we can do transformations through translations, reflections, rotations. We can also look at dilations as well. All right, with that said, we do have one more bit of thing to talk about here, and that's going to be coordinate notation. Now, coordinate notation is one way to write a rule for a transformation in the coordinate plane. Now, the notation uses an arrow to show how the transformation changes in the coordinate plane from x, y. And we'll go through and look here at a second about coordinate notation, but it's just going to be a way of describing what transformation is happening to that shape. So, what's happening from the pre-image to then make it its image, or what we need to do to the pre-image to result in an image. All right. So, with kind of all that terminology out of the way, let's go ahead and take a look at an introduction to transformations and look at what happens. So, let's move this up to our first pre-example. So, this question here is going to tell us find the unknown coordinates for each transformation and draw the image. Then, complete the description of the transformation and compare the image to its pre-image. So, first, they give us this is what coordinate notation is going to look like. So they give us this rule that x, y goes to x minus 4, y minus 3. What this means is you're going to take the points for this A, B, and C. You're going to take those 3 points. Okay, that's your x, y, and you're going to plug them into this coordinate notation, meaning you go through and subtract all the x's by 4, and you subtract all of the y's by 3. So if we look at this diagram, okay, so talk about find each of the points. So A is going to be at 0, 4, B is going to be at 3, 0, and C is going to be at 0, 0. So that is our pre-image. So this is what the starting point is. This triangle is going to be our original image. And I'm going to highlight this a little better so that way we can reference it easier. So that is our starting point. That is our pre-image, our x, y. Now the image, or the transform shape, is going to take place by plugging in these values for x and y into the coordinate notation. So what this means is we take 0, 4, if we plug it in, we're going to get 0 minus 4, 4 minus 3. Okay, I take my value for x, I plug it in for x, my value for y, and for y. So to figure out where your new points are going to end up, means you just go through and simplify. So 0 minus 4 is going to be negative 4, and 4 minus 3 is going to be 1. So using coordinate notation of x minus 4, y minus 3, it moves the point 0, 4 to negative 4, 1. And you're going to go through and do that for each of the points where you're going to subtract 4 to the x's and subtract 3 to all the y's. So to set the rest of this up, we're going to have 3 minus 4, 0 minus 3, and then we're going to have 0 minus 4, 0 minus 3. So when we go through and do that, we get negative 1, negative 3, and then negative 4, negative 3. Alright, so that is going through and applying the transformation to it, and that's going to result in our points. Now, something that we need to do, because we're not quite done with this, okay, just saying negative 4, 1, negative 1, negative 3, negative 4, negative 3 is great, but we have to specify each of these points. So negative 4, 1 is A prime, negative 1, negative 3 is B prime, and negative 4, negative 3 is C prime, meaning points A, B, C were transformed to its primes A prime, B prime, C prime. Alright, now that I have my transformed points, we're now going to go through and draw it on the graph. So A prime is going to be at negative 4, 1. B prime is going to be at negative 1, negative 3. And C prime is going to be at negative 4, negative 3. So I now have my points for A prime, B prime, and C prime. So we just have to go through and connect our dots to get our image. And our image now looks like that. So triangle ABC was then transformed to triangle A prime, B prime, C prime. So we have moved, or we've translated this triangle over here. Now, the transformation, and this is going to kind of be some brief introduction. The transformation is a translation, and we'll talk about that in Module 2, of 4 units. Now, did it move from the left or to the right? So we have to go from the purple to the red. So because the triangle went back 4, that means it went to the left 4 units, and then it went 3 units up or down. Well, purple is the original, so it went back 4 and then down 3. So it went down. And we'll talk about how to identify all of that more later when we talk about translations in section 2.1. Alright, now if we go through and compare the image to its pre-image. Okay, if we look at these two triangles for a moment, okay, and I'm really looking for two things. Okay, if we look at the first thing, is it the same shape? Okay, do these two triangles look like the same shape? In this case, they do, so they do have the same shape. And then, are these two triangles the same size? Okay, if we look at, say, like this side, it's 1, 2, 3, 4. And then this side, it's 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. So the two triangles are, in fact, the same size as well. So comparing the image to the pre-image shows that they have the same shape and size. Now, there's other ways that we could go through and compare these two triangles and talk about them. Main thing that I want to focus on for us is, are they the same shape and size? And you will see why when we get to talking about rigid motions. Alright, so with that said, let's kind of continue on. I do want to talk about a couple different ways of coordinate notation and how it impacts the points and what you need to do. Now, I'm not necessarily going to go through and do every part of these, but just kind of something I want to go through and highlight. So, if we look at part B, our coordinate notation for this is x comma y goes to negative x comma y. So let's talk about what this negative x comma y means. When you have a negative x or a negative variable, okay, and there's no number, in this case it's just negative x, that means you're going to take the sign on all the x values and you're going to change them. So this means if the x value is positive, it's now negative. If it's negative, it's now positive. Okay, something to understand is that just because there's a negative on the x here does not mean that all the x values have to be negative. It just represents that it changed the sign. So in the case of these points here for r, s, and t, that means that instead of negative 4, r prime is going to be positive 4. S prime, instead of negative 1, it's now positive 1. And then t to t prime, instead of negative 4, it's now positive 4. So the negative just means that you change the sign. Positive is now negative, negative is now positive. Now, when you have a variable, y, and it doesn't change at all, so y goes to y, okay, there's no number attached to it, there's no plus or minus, there's no negative, nothing else, okay, it's just the same. That means all the y values stay the same. So for r prime, it stays as 3, s prime, it stays as 3, and t prime stays as 1. So we get 4, 3, 1, 3, and 4, 1 as our new points. And if I go through and plot these real quick, so we have triangle r prime, s prime, t prime. It's going to look like that. Now, based off this part here, it talks about the transformation is a reflection, and we'll talk about how to identify that in Module 2. Is it across the x or the y axis? Well, it's flipping across the y-axis here because we've gone from here to here. So it is a reflection across the y-axis. Now, in this case, okay, looking at these two triangles, okay, just by looking at them, when you ask yourself, does this maintain the same shape and size? In this case, it does maintain the same shape and size. So that is going to be our comparison, that it is the same shape and size. Alright, so what we have seen is adding or subtracting a number to x and y maintains shape and size, and that applying a negative also maintains shape and size. Okay, so that's going to be something that's going to be helpful as we move throughout this lesson. Okay, adding and subtracting, same shape and size. Flipping the sign or attaching a negative, maintain shape and size. Now, I do want to take a look at C before we kind of jump forward to example 1. So in part C here, our coordinate notation is x comma y goes to 2x comma y. So again, I want to go through and talk about what each of these mean. What this part means is that x, what you're going to do is multiply it by 2, and then the y is going to stay the same. Now, the pre-image, so the points, they don't give us on this one. So if we look at our pre-image triangle, okay, point J is at -1, 2. Point K is going to be at 2, 2. And L is going to be at 2, -4. Alright, so I have my points now for the pre-image. I now need to apply coordinate notation to go through and figure out what my image is going to be. Again, 2x comma y means that I'm going to multiply all the x values by 2, and I'm going to leave all the y values alone. So we're going to set it up as j prime, k prime, l prime. I like to go through and do one variable at a time. So let's focus on the x. So 2x means 2 times whatever x is. So we're going to have 2 times -1, which is going to result in -2. Then 2 times 2 is 4. And then 2 times 2 again gives us 4. So my x values are -2, 4, and 4. And then because we just have y, that means all my y values stay the same. So it's 2, 2, and -4. Alright, so I now have my new points for my image. So we're going to go through and draw our new points. So it's -2, 2 for j prime, 4, 2 for k prime, and l prime is going to be at 4, -4. So I now have my new triangle, which is going to look like that. Alright, so that is now my image, my transformed triangle. Now, the transformation is going to be a stretch. Now, does this stretch moving horizontally, or does it stretch vertically? In this case, because it gets longer, okay, horizontally is left to right, so it's a horizontal stretch by a factor of 2, because we multiplied by 2. Now, if we compare our image to its pre-image, are these the same shape and size? Okay, in this case, okay, it is not the same shape and size. Now, I realize in this case that I've gone from a triangle to a triangle, so some of you may be thinking, well, it's the same shape, it's the same figure, but the shape of the triangle has changed. So before, it used to be more narrow, it's now wider, okay? And then the size has changed as well. So, a few things to note: when you add or subtract a number to x and y, it maintains shape and size. When you attach a negative, so you're changing the sign, it maintains shape and size. But the case where it's not going to maintain shape and size is when you multiply or divide a number to x or y. So something to keep in mind: is that it does not maintain shape or size when you multiply or divide.